Today's objective is working on solving literal equations. So in the past, we've actually been solving equations to find the value that makes it true. When we're solving literal equations, we're trying to isolate a variable because oftentimes we're going to have to use that variable to solve for something else. So for example, in science, you might have to manipulate an equation to help you find a speed, a velocity, a distance, or rate, or time by isolating the variable. In mathematics, in geometry, we can also isolate variables to find a length, a width, a height, a volume, an area, and so on. So we're going to practice isolating the variables just like we did before, except we're not going to have a numerical answer. We're going to have a literal equations. That means we're going to have variables as well as constants in them. So for our first example, we have 3x plus 5y equals 24. Here they'd like us to isolate y, so solve for y, get y by itself. So we're going to still use the process from before, talking about getting the variable by itself. So we're undoing those order of operations. So if we're trying to get y alone, notice how this is being added to that, and it's also being multiplied. So we're going to have to undo the order of operations. So we're going to undo the addition by subtracting 3x from each side of the equation. Then we can undo the multiplication by dividing every single term by 5. Well, we know 5 divided by 5, that's 1, so we'd have y. 24 fifths, 24 and 5, they don't have any common factors to divide out, so I would just leave it as is. And then we have a negative 3 fifths. 3 and 5 have no common factors to divide out, so I would leave it as is. And so here we've isolated for y. So we know y equals 24 fifths minus 3 fifths x, or 3x over 5. It means the same thing. And we've accomplished the goal, right? So here's our solving for y. If we wanted to check to see if we verified, to verify that this is correct, we could still do what we did before by taking this expression here and substituting it back in for y here. And when we simplify, we should get our 24 back. So let's try another one. Here again, we want to solve for y. We want to isolate y. So let's think about how we can undo the order of operations. We want to undo this addition of the 5x. So we would subtract 5x from each side of the equation. Then we have to undo this multiplication of negative 2. So we would divide each term by negative 2. Remember, a negative divided by a negative is a positive, so we'd have y here. Positive divided by a negative would be a negative, and there's a common factor of 2 to divide out, so we'd have negative 8. Negative divided by a negative is going to be a positive. 5 and 2 do not have any common factors to divide out, so we'll leave it as is. So here we have y equals negative 8 plus 5 halves x, or 5x over 2. All right, let's solve for y here. So let's isolate it to get it alone. So if we want to get y alone, let's think about the order of operations. So we have some distribution over subtraction that we could take care of first. So we could take 2 times each of the items, x and a negative 5. So we would have 2x minus 10. Now we have some addition we can undo here on the left-hand side. To get y alone, we could subtract 5 from each side of the equation. So we'd have y equals 2x minus 15. All right, let's try isolating y here. So we do have some distribution to undo first, right? So we have 1/2 x plus 3. We have some subtraction to undo, so we could add 9. And we have y equals 1/2 x plus 12. Now, not all equations have variables of x and y. They could be anything, and some will have numbers and some will be all variables, letters. So let's see if we can do something like this. Can we solve for b? Can we isolate b? Well, let's think about this. What is happening with B? B is being added to A, so how do we undo that addition? We subtract. We subtract A from each side, so B equals C minus A. Well, what if this was our equation? A, B, so A times B equals C. Could we undo this to solve for B? We sure can. How do we undo multiplication? Division. If we want to get B alone, we have to undo the multiplication of A. So we'll divide each side by A. So the A's will divide out here and make a 1. So we'd have B equals, C and A are not like terms or have like factors. So we'd have to say that B equals C over A, or C divided by A. What if this was our equation and we wanted to solve for B? Could we isolate it? Well, we have some addition that we can undo here of A, so we could subtract A from each side. Then we have some multiplication we have to undo with division. So we're going to divide every single term by negative 2. Now remember, a negative divided by negative is a positive, and 2 divided by 2, that makes a 1. So we just have B alone, which is what we wanted. A positive divided by a negative is going to be a negative, and there are no common factors here to divide out, so we'll have negative C over 2. A negative divided by a negative, that's a positive, so we're going to have a plus here. And A and 2 do not have any common factors, so we're going to leave that as A over 2. Now notice how they both had a common denominator of 2. We know that when fractions have like denominators, we could add them together. So that's what this is saying here. Here's another equivalent format. Adding them together, negative C plus A over 2 is the same as negative C over 2 plus A over 2. Now some of you may say, wait a second, there's another equivalent format for a result. If both of them are being divided by 2, that's like multiplying by 1/2. So couldn't we write it as B equals negative 1/2 times C minus A? Sure, that's another equivalent format. So because they were being multiplied, right, we're dividing it out, factoring it out, and that's how this gives us our equivalent form for this and for that. So as we get further on, if someone asks for the fully simplified result, this would be the most preferred. But again, they're all equivalent formats of the same thing. All right, one last one. What if this was our equation? Could you solve for B? Well, we have some addition we have to undo. So since we have the A, we could subtract A from each side of the equation. We have some multiplication to undo, so we'd have to do division, and we want to get B alone, so we're going to divide every single term by C. So the C's will divide out and make a 1, so I have B equals, no common factors here, so 4 over C, no common factors here, A over C. So we could write it as B equals 4 over C minus A over C. Now, like we did before, we also could say that since they have the same denominator, we could write them as one fraction. B equals 4 minus A over C. Or, to get even more simplified, we could factor out that dividing by C or multiplying by 1 over C times 4 minus A. Again, all of these are equivalent formats of the same result. This is the most simplified, but again, they're all saying the same thing. So today our theme was solving literal equations. That means isolating a variable and seeing what results, because we're going to apply that to finding other items as we go forward. Now it'll be your time to practice.